Good morning, everyone. So today we are going to talk about the Arrhenius theory. So in the early 1880s, Arrhenius was a chemist who proposed a theory related to acids and bases. According to his theory, the acids are those substances that produce hydrogen ions when dissolved in water, and bases are those substances which produce hydroxide ions when dissolved in water. In other words, in simple words, we can say that hydrogen ions possessing substances are known as acids, whereas the hydroxide ions possessing substances are known as base, right? So that was a major and chief concept of Arrhenius theory. After that, the Arrhenius theory describes that the properties of acids are due to the presence of hydrogen ions, due to hydrogen ions or due to the presence of proton. The properties of acids are due to the presence of hydrogen ions, while the properties of bases are due to the presence of hydroxide ions. Let us concern it with a simple example. For example, here we have a substance which is HCl. HCl has its name as hydrogen chloride or hydrochloric acid. So when we ionize HCl, we have our product as hydrogen and chlorine. So when HCl is dissolved in water, we get hydrogen ion and chlorine as our products. So we can say that HCl is an Arrhenius acid, right? On the other hand side, we have sodium hydroxide. Sodium hydroxide is having hydroxide ions and a sodium ion. So now after dissolving sodium hydroxide in water, we have our product as sodium ion and hydroxide ion. So when dissolved in water, this substance produces hydroxide ions. Thus, this is an Arrhenius base. Sodium hydroxide is an Arrhenius base. That was the first major concept of Arrhenius theory. Secondly, the second major concept of Arrhenius theory was heat of neutralization. Heat of neutralization, what does that mean? That means that Arrhenius theory describes when acids and bases react, the heat is emitted out from acids and bases, which causes to form salt. So we can say that salt is an ionic compound. Salt is an ionic compound that is formed by the reaction of an acid and base. An ionic compound formed by the reaction of an acid and a base. Alongside salt, we have our product as water too, right? So we have salt and water as a product due to the reaction of acid and base. Here we have got an example of an acid reacting with a base. So first of all, we have our acid as hydrogen bromide while base is potassium hydroxide. When both of these react, these hydrogen reacts with the hydroxide ions forming water, whereas the bromide reacts with potassium to form potassium bromide, right? That was the major concept, that acid plus base is equals to salt plus water. After that, the third thing, as the acids and base produce salt and water, it gave for the very first time the concept of catalyst. What is a catalyst? That catalyst is a substance which takes part in reaction but does not involve itself in the reaction and decreases or increases the speed of reaction. So we can say that catalysts are simple helpers which increases or decreases the speed of reaction, which take part of reaction but do not involve in the reaction, right? Now next we are going to discuss, so now we are going to talk about the limitations of Arrhenius theory. Previously we discussed about the aspects of Arrhenius theory, what was the statement and what did the Arrhenius theory describe. Now we are going to discuss the limitations. So first of all, Arrhenius theory describes that hydrogen ions are produced when the substance is dissolved in water. But hydrogen ions, when dissolved in water, react with water to produce the hydronium ions, right? For example, if we have a substance HCl, HCl reacts with water, so it basically forms chlorine ion plus hydronium ions in water, while it does not forms any kind of hydrogen ions individually, right? So that was a major limitation behind Arrhenius theory. Secondly, This theory is only applicable in aqueous solutions. Solutions which contains water are applicable for this theory. We can't dissolve these substances into benzene or other organic substances. Only water. Only water is applicable, not any other kind of substance. Thirdly, this theory cannot explain the acidity of carbon dioxide, basicity of ammonia, and other similar compounds. So that is non-applicable on some substances. So these were the three major limitations of Arrhenius theories which have been described. Now that's all about today's lecture, and tomorrow we'll discuss about the Bronsted-Lowry theory.